Jumbo. Here is another recap of what we've been up to the last day or so on nuclear chemistry. Definition of half-life, nuclear symbols, the mass, atomic number or nuclear charge there, the element symbol, and here's an example. Here are the 5 important particles you should have memorized. Knowing about dealing with nuclear reactions. And some questions will be very straightforward where you fill in the blank. So that's nice. You have all the information but one thing. So usually those are 1-mark questions. And the harder ones is where everything's given in the form of words and you have to write out the whole equation. And so those are challenging. Nuclear fission. Fission means to split, so you can go to Dairy Queen and ask for a banana fission and see what they'll say. And so nuclear fission is taking a large atom on the periodic table and split into smaller atoms, and then it will also give off free neutrons and energy, and of course we like to harness that energy to do things like make electricity, or if we're a little more diabolical, make a bomb. And we have to understand that it produces way more energy in chemical reactions because we're changing the nucleus held together by the strong force rather than the electrons, the outside of an atom in chemical reactions that are transferred more readily. You have to know different aspects of a nuclear reactor. You have to know they're designed to produce electricity. Way back when we did magnets and looked at how you have a generator making electricity. And what we need is to spin a generator shaft. When we talked about hydroelectricity, we're using flowing water to spin the generator shaft. If we're doing a nuclear reactor, we're taking the energy that we make from fission in the form of heat. We're heating up water to the point that it becomes steam. That steam runs through pipes that spin the turbine, and away we go. We make our electricity, like back in the electricity unit. You should know the fuel rods contain the fuel, so it tells you what they do. And the examples we will worry about this year are uranium-235. Control rods control the rate of fission, and often they're made of boron or cadmium. Moderators slow the neutrons. So remember, we want these neutrons like in a big swimming pool, and we want these neutrons to be moving slowly enough that if they make good contact with the nucleus, that they can stick. And if they can stick for a split second, then they can fission. Heavy water, which has a heavier isotope of hydrogen in it, is what's used to slow the neutrons. Neutron reflectors, these would be on the side of the pool in which you're doing your fission under this heavy water. And what they do is, if a neutron misses nuclei, it hits and rebounds, and it may hit a nuclei one of the times it returns after bouncing. We need to shield to protect equipment and protect people from radiation. And things like lead and concrete are done for this. Nuclear reactors are typically set up near a source of water, so you may see them near a river. And the water they will produce will end up being warm, and so they have to have cooling ponds before they're going to be allowed to release that water back into a river. You should know the benefits and the hazards, the problems associated with it, and you should know that the atomic bomb goes with nuclear fission. So the A bomb was split in an atom. Nuclear fusion, on the other hand, if you go into Dairy Queen and ask for a banana fusion, in that case you'd be asking them to put 2 bananas together. So when we talk nuclear fusion, we're talking about trying to force 2 hydrogen nuclei together, 2 positively charged particles that don't want to go together. We're going to make them go together. And that means it takes enormous energy, heat, and pressure to do that. And in fact, there's no physical container that can do that, so it's done in a force field. Now, if you recall, you just did an astronomy unit, nuclear fusion is going on all the time in stars. Stars are basically fusion reactors of hydrogen into helium, among other things. So we should know the pluses of being able to do nuclear fusion, and we should know why it hasn't been done on a large scale, and we should know that the hydrogen bomb is a fusion bomb. So that's a recap of what we've been up to the last couple of days.